Section 404.8 of the National Electrical Code requires that fuse switches shall be readily accessible for inspection and replacement of fuses. The intent of this requirement is to ensure that personnel can safely access the fuse switches for maintenance and repairs. Hook sticks or ropes are necessary to access fuse switches that are installed at high elevations, such as 15 feet above the working surface. The use of hook sticks or ropes provides a safe and convenient method for accessing the fuse switches without the need for ladders or other climbing equipment. Providing a hook stick every so many feet may not be sufficient to meet the requirement for ready accessibility. Fuse switches should be accessible from all directions to allow for safe and efficient maintenance. Therefore, a hook stick or rope should be provided for each fuse switch. The requirement for readily accessible fuse switches is outlined in the National Electrical Code, specifically Section 404.8. This section mandates that fuse switches must be easily accessible for inspection and fuse replacement. The rationale behind this code is to guarantee that maintenance and repair personnel can safely reach the fuse switches when necessary. When fuse switches are installed at elevated positions, such as 15 feet above the working surface, hook sticks or ropes become essential tools. These tools provide a safe and convenient way to reach the fuse switches without the need for ladders or other potentially hazardous climbing equipment. The use of hook sticks and ropes ensures that workers can perform maintenance tasks without compromising their safety. Simply providing a hook stick at intervals of several feet might not adequately meet the accessibility requirements of the code. Fuse switches should be accessible from multiple directions, allowing for efficient and safe maintenance procedures. Therefore, it is crucial to have a dedicated hook stick or rope available for each individual fuse switch. This ensures that workers can easily reach any switch from any angle, facilitating prompt and effective maintenance. Let's delve a bit deeper into the concept of readily accessible as it applies to electrical installations. Readily accessible, as defined by the NEC, means capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. The specific height of 15 feet for a busway installation brings the ready accessibility requirement into sharper focus. Because at that height, direct access is clearly not possible without additional equipment. Therefore, the code mandates the provision of either a hook stick or a rope for each fuse switch. Consider the practical implications of this rule. Firstly, it ensures that in the event of a fuse failure or the need for inspection, maintenance personnel can quickly and safely isolate the affected circuit. Secondly, it minimizes the risk of electrical shock or other injuries that could result from attempting to access the switch in an unsafe manner. Thirdly, it promotes efficient maintenance practices by eliminating the need to search for a shared hook stick or to maneuver ladders around obstacles. The code's intent is to create a safe and efficient working environment for electrical workers. It is also important to note that the AHA, or authority having jurisdiction, has the final say in interpreting and enforcing the NEC. The AHA may have specific requirements or interpretations regarding the placement and availability of hook sticks or ropes for fuse switches. Therefore, it is always a good practice to consult with the AHA before installing or modifying electrical systems. Furthermore, proper training and safety procedures are essential when working with electrical equipment. Only qualified personnel should be allowed to perform maintenance or repairs on fuse switches. These personnel should be thoroughly familiar with the NEC requirements, as well as any applicable safety regulations. In summary, Section 404.8 of the NEC mandates that fuse switches must be readily accessible for inspection and fuse replacement. For busway installations at a height of 15 feet, this means that each fuse switch must have a dedicated hook stick or rope readily available. This requirement ensures the safety and efficiency of electrical maintenance operations. Now let's talk a bit more about busways. A busway is a prefabricated electrical distribution system consisting of bus bars enclosed in a protective housing. Busways are used to distribute power from the service entrance to various points throughout a building. They are often used in industrial and commercial buildings where there is a need for a flexible and reliable power distribution system. Busways are available in a variety of sizes and configurations to meet the specific needs of a particular application. They can be installed horizontally or vertically, and they can be suspended from the ceiling or mounted on walls. Busways offer a number of advantages over traditional wiring methods, including ease of installation, flexibility, and reliability. They can be easily reconfigured or expanded to meet changing power requirements. They are also less susceptible to damage from vibration and other environmental factors. Fuse switches are commonly used in busway systems to provide overcurrent protection for individual circuits. A fuse switch is a combination of a switch and a fuse. The switch is used to disconnect the circuit, and the fuse is used to protect the circuit from overcurrent. Fuse switches are available in a variety of sizes and types to meet the specific needs of a particular application. They are typically installed in a panel board or switchboard. The NEC provides detailed requirements for the installation and use of fuse switches. These requirements are intended to ensure the safety and reliability of electrical systems. The NEC also provides requirements for the accessibility of electrical equipment, including fuse switches. As we have discussed, Section 404.8 specifically addresses the accessibility of fuse switches. In addition to the hook stick or rope requirement, the NEC also requires that the working space around electrical equipment be clear and unobstructed. This is to ensure that workers have enough room to safely perform maintenance or repairs. The working space must be at least 3 feet deep, 30 inches wide, and 6 feet 6 inches high. The NEC also requires that there be adequate lighting in the working space. The lighting must be sufficient to allow workers to safely see what they are doing. In addition to the NEC requirements, there may be other applicable safety regulations that must be followed when working with electrical equipment. For example, OSHA, the Occupational Safety and Health Administration, has a number of regulations that apply to electrical work. These regulations are intended to protect workers from electrical hazards. It is important to be familiar with all applicable safety regulations before working with electrical equipment. When working with electrical equipment, it is always important to use safe work practices. This includes wearing appropriate personal protective equipment such as gloves and eye protection. It also includes following lockout/tagout procedures to ensure that the equipment is de-energized before any work is performed. By following safe work practices, you can minimize the risk of electrical shock or other injuries. Let's explore some common scenarios where the hook stick or rope requirement for fuse switches on busways would apply. Imagine a large manufacturing plant with a complex electrical distribution system. The busways are installed high above the factory floor to save space and avoid obstructing the movement of equipment and personnel. In this scenario, each fuse switch on the busway must have a readily accessible hook stick or rope. This allows maintenance personnel to quickly and safely isolate circuits in the event of a breakdown or the need for routine maintenance. Another example is a high-rise office building with a vertical busway system that distributes power to each floor. The fuse switches on the busway are located in electrical closets on each floor. In this case, each fuse switch must have a hook stick or rope readily available within the electrical closet. This ensures that building engineers can quickly and safely address any electrical issues that may arise. Consider a data center with a critical need for uninterrupted power. The busway system is designed with redundant circuits and fuse switches to ensure that power can be quickly restored in the event of a failure. In this type of facility, the ready accessibility of hook sticks or ropes for each fuse switch is even more crucial. It allows technicians to quickly isolate and repair faulty circuits, minimizing downtime and preventing data loss. In all of these scenarios, a hook stick or rope serves as a critical safety tool. It allows workers to access the fuse switch from a safe distance, reducing the risk of electrical shock or arc flash. It also eliminates the need to climb ladders or use other unsafe methods to reach the switch. The location of the hook stick or rope is also important. It should be stored in a location that is easily accessible and clearly marked. It should also be protected from damage or contamination. Some facilities choose to store the hook stick or rope directly on the fuse switch enclosure. Others prefer to store it in a nearby cabinet or rack. Regardless of the storage method, the key is to ensure that the hook, stick, or rope is readily available when needed. In addition to the physical presence of the hook, stick, or rope, it is also important to have clear procedures in place for its use. Workers should be trained on how to properly use the hook, stick, or rope to operate the fuse switch. They should also be aware of the potential hazards associated with working with electrical equipment. Regular inspections of the hook, sticks, and ropes are also important. This is to ensure that they are in good condition and ready for use. Any damaged or worn hook, sticks, or rope should be replaced immediately. The importance of following the NEC requirements for readily accessible fuse switches cannot be overstated. These requirements are designed to protect workers from electrical hazards and to ensure the safe and reliable operation of electrical systems. By understanding and adhering to these requirements, you can help create a safer working environment for yourself and your colleagues. To reiterate, the National Electrical Code, specifically Section 404.8, mandates readily accessible fuse switches for inspection and fuse replacement. When fuse switches are positioned at elevated locations, such as 15 feet above the working surface on a busway installation, it becomes imperative to have a dedicated hook, stick, or rope readily available for each switch. The intent behind this requirement is to prioritize safety and ensure efficient maintenance procedures. It is crucial to remember that providing a shared hook, stick at intervals might not be sufficient to meet the code's requirements. Each fuse switch should have its own dedicated access tool to facilitate maintenance from all directions. This ensures that workers can quickly and safely isolate circuits, minimize the risk of electrical hazards, and maintain the reliable operation of the electrical system. Compliance with the NEC and adherence to safe work practices are paramount when working with electrical equipment. Let us continue this discussion by considering some best practices for maintaining hook, sticks, and ropes used for operating fuse switches. Firstly, implement a regular inspection schedule. Hook, sticks, and ropes should be inspected at least annually or more frequently if they are used often or exposed to harsh environments. The inspection should check for signs of wear, damage, or deterioration. Look for cracks, splinters, fraying, or any other condition that could compromise the integrity of the tool. Secondly, establish proper storage procedures. When not in use, hooks, sticks, and ropes should be stored in a clean, dry, and protected location. Avoid storing them in direct sunlight or near sources of heat or chemicals, as these can damage the materials. Consider using a dedicated storage rack or cabinet to keep the tools organized and easily accessible. Thirdly, implement a tagging system. Each hook, stick, and rope should be tagged with an identification number and a date of last inspection. This allows you to track the maintenance history of each tool and ensure that inspections are performed on schedule. The tag should also include information on the tool's safe working load or maximum operating voltage. Fourthly, provide training on proper use. All personnel who are authorized to use hooks, sticks, and ropes should receive thorough training on their proper use. This training should cover topics such as how to inspect the tools, how to safely operate fuse switches, and how to recognize and avoid potential hazards. Fifthly, establish a replacement policy. Hooks, sticks, and ropes should be replaced immediately if they are found to be damaged or worn. It is also a good practice to replace them on a regular schedule, even if they appear to be in good condition. This helps to ensure that you are always using tools that are in optimal condition. Sixthly, document all inspections and maintenance activities. Keep a detailed record of all inspections, maintenance, and repairs performed on hook, sticks, and ropes. This documentation can be used to track trends, identify potential problems, and demonstrate compliance with safety regulations. Seventhly, consult manufacturer's recommendations. Always refer to the manufacturer's recommendations for the specific hooks, sticks, and ropes that you are using. The manufacturer may have specific instructions on inspection, maintenance, and storage. Eighthly, consider using insulated tools. If you are working with energized electrical equipment, consider using insulated hooks, sticks, and ropes. These tools are designed to provide an extra layer of protection against electrical shock. Ninthly, promote a safety culture. Encourage all personnel to prioritize safety when working with electrical equipment. Emphasize the importance of following proper procedures and using appropriate tools. 10thly, review and update procedures regularly. Regularly review and update your procedures for inspecting, maintaining, and using hook sticks and ropes. This will help to ensure that your procedures are always up to date and effective. By following these best practices, you can help to ensure that your hook sticks and ropes are always in good condition and ready for use. This will help to protect workers from electrical hazards and to ensure the safe and reliable operation of electrical systems. In addition to these best practices, it is also important to be aware of the potential hazards associated with working with electrical equipment. These hazards include electrical shock, arc flash, and falls. To minimize the risk of these hazards, it is important to follow all safety procedures and to use appropriate personal protective equipment. Working on electrical equipment can be dangerous, but by taking the necessary precautions, you can help to ensure your safety and the safety of others. Let's expand upon the discussion about the selection of appropriate hook sticks and ropes for fuse switch operation on busways. The selection process should consider several factors to ensure both safety and functionality. Firstly, voltage rating is crucial. The hook stick or rope must be rated for the maximum voltage of the electrical system. The tools should be tested and certified to withstand the voltage without conducting electricity to the user. Secondly, material composition matters. Hook sticks are often made of fiberglass or other non-conductive materials. Ropes can be made of synthetic fibers such as nylon or polyester, which offer strength and resistance to electrical conductivity. Thirdly, length is a critical consideration. The length of the hook stick or rope should be sufficient to allow the user to safely operate the fuse switch from a comfortable distance, taking into account the height of the busway and any obstructions. Fourthly, grip and handle design are important for ease of use. The hook stick should have a comfortable grip that allows for a firm hold, even with gloves. The rope should be easy to grasp and manipulate. Fifthly, hook design is significant for secure engagement with the switch operating mechanism. The hook should be designed to securely engage with the operating handle or lever of the fuse switch, preventing slippage during operation. Sixthly, weight is a factor to consider, especially for prolonged use. The hook stick or rope should be lightweight enough to prevent fatigue during extended use. Seventhly, environmental conditions should be considered. If the hook stick or rope will be used in harsh environments, such as those with extreme temperatures or exposure to chemicals, it should be made of materials that are resistant to those conditions. Eighthly, compliance with standards is essential. The hook stick or rope should meet relevant industry standards, such as those established by ANSI, ASTM, or IKE. Ninthly, ease of maintenance should be taken into account. The hook stick or rope should be easy to clean and maintain. Replacement parts should be readily available if needed. Tenthly, cost effectiveness should also be considered. The hook stick or rope should be priced competitively while still meeting all safety and performance requirements. Selecting the appropriate hook stick or rope is a critical step in ensuring the safety of electrical workers. By considering these factors, you can choose a tool that will provide years of reliable service. The selection process should also involve input from electrical workers who will be using the tools. Their experience and expertise can be invaluable in identifying the features that are most important for safety and functionality. Remember that safety should always be the top priority when working with electrical equipment. By taking the time to select the right tools and following proper safety procedures, you can help to prevent accidents and injuries. Finally, let's consider some specific details regarding the National Electrical Code, specifically Section 404.8, as it relates to the accessibility of fuse switches on busways. The NEC does not explicitly define the exact type of tool required for accessibility, but it does emphasize the importance of ready access for inspection and fuse replacement. The intent of the code is to ensure that workers can safely and efficiently perform maintenance tasks on fuse switches. The ODGE, or authority having jurisdiction, has the final say in interpreting and enforcing the NEC. The AHA may have specific requirements or interpretations regarding the placement and availability of hook sticks or ropes for fuse switches. Therefore, it is always a good practice to consult with the AHJ before installing or modifying electrical systems. The NEC also contains other relevant sections that may apply to the installation and maintenance of fuse switches on busways. These include sections on working space around electrical equipment, guarding of live parts, and personal protective equipment. It is important to be familiar with all applicable NEC requirements before working with electrical equipment. The NEC is updated on a regular basis, so it is important to use the latest edition of the code. The NEC is available from the National Fire Protection Association. In addition to the NEC, there may be other applicable safety regulations that must be followed when working with electrical equipment. For example, OSHA, the Occupational Safety and Health Administration, has a number of regulations that apply to electrical work. These regulations are intended to protect workers from electrical hazards. It is important to be familiar with all applicable safety regulations before working with electrical equipment. Working on electrical equipment can be dangerous, but by taking the necessary precautions, you can help to ensure your safety and the safety of others. Always follow proper safety procedures, use appropriate personal protective equipment, and consult with the AHJ before performing any work on electrical systems.